Hello my dear students and viewers. Welcome to our YouTube channel Career Plus once again. Myself Bernoulli Muzundar going to discuss about Bernoulli's theorem today and its some important application which is applicable in our day-to-day life. Let's start from Bernoulli's theorem. Bernoulli's theorem is applicable for fluid motion. Fluid means liquid or gaseous medium. Mathematically it forms that where P is the pressure of the fluid and rho density of the fluid, V velocity of the fluid. If the fluid means gas or liquid flows horizontally, that is parallel to the earth's surface, H becomes constant. So as a result, for that purpose, H rho Z, the whole term becomes constant. So for that specially we'll get that one, P plus half rho V square is equal to constant. This is only for the steady flow, only for the steady flow if horizontal, if horizontal. Now it is clear from the above equation that since rho is constant, the two term P plus that one, this is first term and that one second term, the summation of the whole term becomes constant. It means that if one term increases, then other term decreases. So we can say that one, if P increases, we can say V decreases. That means if velocity of the fluid decreases, then pressure increases, or vice versa. It means that if velocity increases, as a result pressure becomes decreases. Now we can explain why during windstorm roofs of houses are blown off. Say this is the steady condition, this is the house. During windstorm, when velocity of air just above the roofs becomes increases, as a result what is going to happen? Pressure outside or above the roofs decreases, but inside the house the pressure remains constant as it was earlier. So what is going to happen? We can conclude that pressure just below the roofs becomes greater than the pressure just above it. So there is a difference of pressure, and as a result the roofs of the house are blown off. Then finally we will get that one, and it is quite common to say during windstorm. Before going to the last part of this session today, my simple request is to subscribe our channel Career Plus for such type of videos and keep watching it. Thank you everyone. Now we are going to discuss why it becomes more dangerous when we stand in a railway track through which a fast moving train crosses. Let's start from the See, one person stands nearby the track and at the same time a fast moving train just crossing through the track. Then that person has a tendency to fall towards the train. Can you guess why so happen? It's very simple now. As we have studied, when V increases, P decreases, or vice versa. Same thing happening here also. When train moves in a fast way, then the velocity of the air molecules of that side, of the left side of the person, becomes increases. As a result, the air pressure of the air molecules on the left side the person decreases. But think what will happen about the pressure on the right side of the person? It becomes constant as earlier. So that means there is a difference of pressure on the right side as well as on the left side. So as a result, since amount of pressure on the left side of the person becomes less than the right side, so we or that person has a tendency or feels that someone pushing him towards the train.